Hello and welcome to the video today. This video continues our series on exam style questions for A-level and Scottish Higher Maths. Today we're looking at a question involving logarithms. The question says evaluate 2 log 10 to the base 5 minus log 4 to the base 5. We'll just quickly go over a few rules of logarithms. So you should know these if they're not given in a formula booklet. So the log of a to the n is equal to n log a. Just remember to put in your base. If you're not given a base to work with, always write the base down. And then the log of x plus the log of y. So the sum of two logs is just the log of the product. So log of x plus log of y equals log of xy. The difference of two logs is the log of the quotient. Log of x minus log of y equals log of x over y. Again, remember to put your bases in if you're not told what the base is or what base to use. If you're not specifying a base, write the base down, because the answer will change depending on the base, which we'll see in a minute. Okay, so these are the three most commonly used laws of logarithms that you'll be using to help solve problems. Okay, so a few things to note. Log of x, just log of x written like that without a base, usually means to the base 10. And this is known as the common log. You'll see this on your calculator. On your calculator, you'll see log on a button. And if you evaluate any number and press that log button, it's actually using base 10. Okay, so log of x technically means log of x to the base 10. And the other one you'll see a lot is ln of x, but it's usually stated as log of x as well. We don't usually say ln of x or ln of x. We just say log of x. But in that case, that is equal to the log of x to the base e, where e is the exponential number. So the function e is the inverse of the ln function, the inverse of the log function. Now ln literally means logarithm naturalia, so it's the natural log. So that's the log to the base e. Okay, so these are the two most common ones. These are on a calculator. So one is to the base 10, the common log, one is to the base e, the natural log. But in questions, they may give you a base to work with. So these are neither common log or natural log. This is just a custom base. Okay, base can be anything. Okay, so let's remind ourselves what a log is and what it means and how the base can affect it. So a log on its own, if you just write log of 64 like that on its own, and I ask you to evaluate that, what's the log of 64? Well, you won't be able to tell me because it doesn't make sense without a base. Okay, but if I give you a base, so if I say log of 64 to the base 4, then just remind ourselves, a log is the power to which you raise the base to give you the number. So it's the power I need to raise 4 by to give me 64. Okay, so if we call it x, so then 4 to the x equals 64. And then x is equal to 3. So the log of 64 to the base 4 is equal to 3. So the base is very important and necessary. Now if we change the base, suppose we change it to the base 8. So without the base, you could say, if I scribble out the bases, log 64, it's the same, isn't it? But when I put a base in, they're different. They're very different, okay? So again, we apply the same rule. The power to which the base is raised to give you the number. 8 to the x is 64, x equals 2. So there you go. So the log of 64 to the base 4 is 3, the log of 64 to the base 8 is 2. So the answer will change depending on the base. Okay, so let's get into this question. Now, as I say, we're going to need to use rules of logarithms over here to answer this. So let's go. So 2 log 10 to the base 5. Don't worry about the base just now. let's just focus on the 2 log 10 bit. So the 2 log 10, we can write that as the log of 10 squared, the log of 10 to the 2. And we'll put our wee base in, okay? Why is that? Well, we're basically using this rule here, but we're doing it the other way. We're saying n log a is equal to this. So we're rewriting this as log a to the n. Sometimes you will go the other way, but we're going this way, okay? And then that's minus log 4. We can't simplify log 4 at this point. Okay, and what's that? So that's equal to the log of 100, because you know 10 squared is 100, to the base 5, of course. Don't forget your base. Now you could omit the base, as long as you remember to put it back in again at the end, but it's better to, good practice to keep it there. Okay. Okay, so now we've got this. Again, 5 to the something equals 100. That is not an integer, okay? Because 5 squared, 5 to the power 2 is 25. 5 to the power of 3 is 125. So the answer, log of 100 to the base 5, is somewhere between 2 and 3. So it's not an integer. And this is definitely not an integer, because you're taking the log of a number to a base which is higher than the number. So this is going to be less than 1, okay? So that's definitely not an integer. But as I say, we can actually simplify this nicely, and we use our third rule over here. The log of a difference is equal to the log of the quotient. The difference of logs is equal to the log of a quotient. Okay, so let's use that. So the log of x minus the log of y is equal to the log of x over y. So that's equal to the log of 100 over 4, and then put your base. Great, so now we just tidy this up. So that's the log of 25 to the base 5. Okay, so this is our answer, log of 25 to the base 5, okay, but we need to obviously do the final step to get the answer. So let's call that x. So that's equal to x. And that implies 5 to the x equals 25. So x is equal to 2. So that's our answer, guys. So 2 log 10 minus log 4, and we're working in base 5, is equal to 2. Okay, so that's it. That's basically it. Yeah, so if you know your laws of logarithms, and just remember, keep a note of the base that you're working in. And an expression like that, which can look very ugly, it can be quite intimidating, like how you're going to work that out, can actually become quite simple once you use your laws of logarithms. Okay, so the answer is 2. Now, one thing I'm just quickly going to cover here, because I think it's useful. Let me scribble this out. Okay, now that we've solved the problem, I just want to cover a wee thing here which might help you. As I was saying earlier, the log of 10 to the base 5, we know it's going to be bigger than 1, because log of 5 to the 1, 5 to the 1 is 5, and 5 is less than 10, so it has to be bigger than 1, and we know that it has to be less than 2 because 5 squared is 25. So what you can do is, before you even evaluate this thing, you can work out an estimate of what it roughly might be, so that way you know that when you get to the end, you know if you're on the right track. Because if you're way off on your answer, you know you've done something really wrong. So it always helps in maths, when you're doing maths questions and evaluating things, it always helps to have an estimate. So let's see. So for this one here, let's suppose, what's an estimate? Well, the log of 10, sorry, to the base 5, well, that's going to be in the interval 1, 2, because since 5 to the 1 equals 5. 5 to the 2 equals 25. And obviously 5 is less than 10, less than 25. Okay, and then if we apply that same logic to the other one, so the log of 4 to the base 5, well, that's going to live in the interval 0, 1, since 4 to the 0 equals 1. Sorry, 5 to the 0 equals 1, I meant to say, sorry. And 5 to the 1 equals 5. And 1 is less than 4 is less than 5. Okay, so if we write this one here, 5 to the 1 less than 10 less than 5 to the 2. And then this one, 5 to the 0 less than 4 less than 5 to the 1. Okay, so 4 is between 5 to the 0 and 5 to the 1, okay? And 10 is between 5 to the 1 and 5 to the 2, okay? So that means the log of 10 to the base 5 is between 1 and 2, strictly between 1 and 2. The log of 4 to the base 5 is strictly between 0 and 1. Okay? So that means 2 log 10 minus log 4. So it's a number which is strictly between 1 and 2, 2 times a number between 1 and 2, minus a number which is between 0 and 1. So, what's the most it could be? Well, the most it could be is when this is maximized and this is minimized. So when this is maximized, it's 4. So the max is equal to 2 times 2, and this is minimized when it's 0, minus 0, which is 4. But it's never equal to 4, it's definitely less than 4 because this here is less than 4. Okay, this here is less than 4, okay? So even if you took 0 off, you're still going to have a number less than 4. And you're taking at least 0 off. You're going to be taking at most 1 off. So this is always going to be less than 4, guaranteed. Okay, so that's the max it could possibly ever be. This is like a supremum, if you like. And then the min, now that's when that is minimized and that is maximized. So when that's minimized, it's 2, 1. And that's maximized at 1. So 2 times 1 is 2, minus 1 is 1. Okay, so your answer will be between 4 and 1, or 1 and 4. So your answer, x, so that means x will be strictly between 1 and 4, where x is the answer to that. So evaluate 2 log 10 minus log 4. And to the base 5, okay? So that answer there will be between, it's equal to x, but it's between 1 and 4, okay? I know that before I even apply any logs to evaluate it, okay? Just using some logic, okay? So that's an estimate, okay? Now, so that means if I got an answer, say like 10 or 20 or minus 3 or some weird answer like that, which wasn't in that interval, then I know I've done something wrong. Okay guys, so thanks for watching the video, and I'll see you on the next video. We'll be covering more exam style questions. So stay tuned for more of these. Thanks for supporting the channel. Please like, share and subscribe, and I'll see you soon.